This is an Algebra 2 worksheet on inverse and direct variance, and I will do one of each. Let's see, that's the one I'll do for inverse is 23. I'll do 24 for directly. So it says the distance an object falls, let me get this set up so I have my pen the way I want it. Okay. The distance an object falls from rest varies directly as the square of the time it has fallen. So direct variation means d, the distance an object falls, varies directly, so it would be equals k times the time it was falling. That's direct variance. Inverse variance would be d equals k over t. But that's not what I'm using for this one. This one's direct. So what is a constant of variation? Well, it's got to give me some values. It says the object fell 4 feet during the first half second. So distance is 4 feet equals k. Oh, it said the square. So it's the square of t. And if it was the square of t, inversely, it would be that. I forgot the square part. Why didn't you tell me about that? All right, so 4 equals k times 1/2, so a half second squared. And 1/2 squared is 1/4, so this becomes 4 equals 1/4 k. And if I multiply both sides by 4, I get k equals 16. So k is 16. Now what is the direct variation equation? It's going to be d equals 16 t squared. How far did it fall during the next 2 seconds? Well, I know it fell 4 feet during the first half second, and I will find the distance it falls during the first 2.5 seconds, subtract the distance it fell during the first half second, and then I'll have it. So let's see, it says next 2 seconds. So that would be a total of 2.5 seconds. I'm going to put, that should be distance. How far did it fall? So distance equals 16 times 2.5 seconds, which is 5/2. 5/2 is 2.5 squared, because it's kt squared. And so 5/2 squared is 16 times 25 over 4. And 4 goes into 4 once, 4 goes into 16 4 times 25 equals 100. So that's how far it fell during the first 2.5 seconds. And so to find out how far it fell during the next 2 seconds, I'll take the 100 that it fell during the first 2.5 seconds, subtract how far it fell during the first half second, and I get that it fell 96, are these feet? It fell 96 feet during the next 2 seconds. So that's it. And now I have one more. I'm going to do one with inversely proportion. By Ohm's law, the current, I'm just going to write it here without the k value, and then I'll put the k value in. The current is inversely proportional, so that means k is divided by what it's inversely proportional to R. So let's see. The current is 5 amps when the resistance is 24. So 5 equals k over 24. So what is k? K equals 5 times 24. $120. That doesn't look like a 2. Man, that's a bad 2. Let me fix that 2. K equals 120. And then I can find the formula with the k. It's 120 over R. And now for what resistance will the current be 8? So 8 equals 120 over R. And let's see, I multiply both sides by R, divide by 8. R equals 120 over 8 equals 8 times 1 is 8, 40, 15. So it's 15. So again, the formulas are, I'll just write them up here. For general direct variance, it's y and whatever these variables are equals kx. And for indirect, it's y equals k over x. Those are the basic formulas. And I've done 2 examples. One was a little bit more complicated because it had the t squared, and it was indirect variation. So it was where was this one? This one. It was going to be, oh no, that was direct variation. So it was d equals kt squared, because it was direct variation. And then the other one with Ohm's law was inverse variation. But that's how you do them with those two formulas, direct and inverse.